Hi everyone, in this video I'm going to go through section 4.3 of the Lab 4 handout, which is building and testing the output amplifier. For this part of the lab, you're going to need an op-amp, two resistors, 20 kiloohm and 6.8 kiloohm, as well as a 220 microfarad DC blocking capacitor. I'm first going to place my op-amp in the circuit. I'm going to connect the inverting terminal of the op-amp to this node here. With that, I can connect resistor R1 of 20 kiloohms between the output terminal and then the inverting terminal of the op-amp. Now, the 20 kiloohm resistor has a color combination of red, black, orange. So take out a red, black, orange resistor from your kit and then connect it between the output terminal and then the inverting terminal of the op-amp. Next, I'm going to connect resistor I2 between the inverting terminal of the op-amp and the ground rail. I2 has a value of 6.8 kiloohms, which corresponds to a color combination of blue, gray, red. So take out a blue, gray, red resistor from your kit and then connect it between the inverting terminal of the op-amp and the ground rail. The last step is to connect our DC blocking capacitor. Make sure that this capacitor is put in the right polarity so that the positive terminal corresponds to the output terminal of the op-amp and not vice versa. With that, we can connect our scope channel 1 and channel 2 cables. The channel 1 measurement will be the non-inverting terminal of the op-amp, since that's where we're going to be applying our input voltage, and the channel 2 measurement will correspond to the output of the DC blocking capacitor. Lastly, I'm going to connect my waveform generator input to the non-inverting terminal of the op-amp, and now we're ready to test our output amplifier circuit. Head over to the Waveforms app and use the waveform generator to test the output amplifier with a sinusoid at a frequency of 5 kHz and an amplitude 500 millivolts. Press run, then head over to the oscilloscope, which is where we're going to measure the gain of our output amplifier. But before you perform a single acquisition on the oscilloscope, you need to power the op-amp with the power supplies of plus or minus 5 volts. So in my circuit, I forgot to connect the op-amp with the V plus and V minus rails. So connect the V plus node of the op-amp to the positive power supply, and then connect the V minus node of the op-amp to the negative power supply. With that, we can head back over to the Waveforms app, go to the supplies application, enable it, and then set the positive and negative power supplies to be plus or minus 5 volts. Now we can head back over to our oscilloscope and perform a single acquisition of our output. As we can see, if I head over to the measurements, then add peak-to-peak measurements for channel 1 and channel 2, the ratio of the peak-to-peak voltages of the output and input sinusoids is 3.94, which is approximately equal to 4. Alright, so we've successfully built our output amplifier that has an approximate gain of 4. The last thing I'm going to do is I'm going to connect the IF filter, envelope detector, output amplifier, and DC blocking capacitor together so that we can actually have a working superheterodyne receiver. To do that, first disconnect the waveform generator, and then connect the wavegen input to the input terminal of the IF filter. Next, I'm going to connect the output voltage of the envelope detector to the non-inverting terminal of the output amplifier. And then I'm going to connect the output voltage of the IF filter to the input of the envelope detector. So we've successfully built a working AM superheterodyne receiver, and in the next video I'm going to go through section 5 of the lab handout, which is actually testing or AM superheterodyne receiver.